Hi, in this video, I'll brief you about the cell and pack ACIR testing. The ACIR is a very important parameter to understand the cell's health and also the pack's health as well. Apart from these two constraints of a health, it is also good to understand when you manufacture a battery pack because of many different components. Maybe it is a bus bar or an electrical conductor between the cell and the integration of cell components. Maybe it's a welding process. Then finally, the contact between the bus bars to an electrical output to the outside world. All of these components contributes to our internal resistance. Apart from the pack level, or to the cells level, right? So when you measure the ACR of the cell, it gives you a significant information that what is the internal resistance of that cell. So when you perform an ACIR test, mostly you're performing at 1 kilohertz frequency, and also you perform at a specific state of charge. If you read the datasheet of the cell, mainly, in the datasheet they'll tell you that the ACIR of the cell, that means mostly it is done at room temperature and also done at 50% state of charge. So the machine helps you to conduct an experiment, and the data from that machine will help you to understand whether the cell supplied by the supplier is within the specific given range of our AC internal resistance. And also, if you want to do it at the pack level, that data that is coming from the pack will help you to understand whether that pack is within the given limits of the AC internal resistance. When we make this activity of measuring a cell's or a pack's ACIR, it helps you to know the internal resistance of the cell. So where does this information is very useful? If you take an activity of a production plant, right? If the supplier has given you many number of cells, maybe lakhs of cells, before you put the cells into the pack, it is very important to understand whether all the cells in the pack will have the same internal resistance. So this process is used for the sorting of the cells. And the second important thing is that when you manufacture a battery pack, at the end of production line, you want to verify all your production process has met a given required conditions so that the final internal resistance, AC internal resistance of the pack, is within the limits of the given range. And also in the field, for example, if there is any faults coming back from the field, without removing the battery pack, you can check the AC internal resistance. So you can measure and compare the data with what is permissible in the data sheet of the battery pack supplier. So henceforth, it gives a very important activity as a tool for us to test the IR value of the cell at a very less time and gives you information to make certain decisions. So for that today, we have Hioki PT3562A. This machine comes up to a range of 100 volts. So within the range of 100 volts, we can measure any pack's ACIR. Also, you can measure the cell level as well. To make this demonstration happen, so we have various number of packs and also a variety of cells. So to give you a quick demonstration, so we have the negative probe of the cell and the positive probe of the cell. So, and it comes with the two terminals for us to test, and we call it as a 4-probe measurement approach. So for this one, so we can see the data here. It gives you the voltage and also it gives you the AC internal resistance. So we keep a cell here and we probe the cell, and you can get to see the cell voltage is about 2.761. The internal resistance is about 2 milliohms. And typically for an LFP cell, you have a very low internal resistance. And you can also measure it for a prismatic cell as well. Let's take a prismatic cell and see if you're able to make the measurement on the prismatic cell as well. So you can see that, I know it's difficult to see, that the internal resistance of the prismatic cell is very, very less. It's about 0.33 milliohms. And the same way, if we take an example of a NMC cell, here we have a Samsung cell of a specific 18650 size. So let's measure the internal resistance of this cell. So you can see that the internal resistance of this cell, right, is about 31.73 milliohm. That means it is comparatively higher than compared to an LFP, cylindrical, and a prismatic cell. In the same way, we can also do a measurement of the pack ACIR as well. For that, I'll take an assistance of my teammate here. So we have the battery packs here, and we can see that where we will be able to measure the internal resistance at a pack level as well. So if you see here, so that at a pack level we have 203.7 about that value at a voltage of 49.46. That means when we measure the internal resistance at a pack level, because of the interconnections, the conduits and all the components and even the connectors will add up the internal resistance also. So in this way, it gives you a very important information to know and understand how to measure and understand the cells and packs AC internal resistance. What else you can do? You can also keep the cells inside a thermal chamber and test the internal resistance maybe at 10 degrees Celsius, at -10, +45, and things like that, which helps you to know a key information of the AC internal resistance at a 1 kilohertz frequency. With this way, this is very useful for teaching students on how to use right equipment at right places to know the idea of cells and packs internal resistance, maybe for a cell level identification, but also a pack level identification in the production plant, or else in the R&D activities as well. So that's pretty much about what you can do with the help of cell or pack ACIR machine. Thank you very much.